In previous class we have discussed work done, and according to science, work done is defined as it is the scalar product of force and displacement, that is W equal to F dot D or W equal to Fd cos theta, and the unit of work is joule or Newton meter. The work may be positive, negative or zero depending on the angle between force and displacement. If the angle between force and displacement is acute, that means less than 90 degree, work done is positive. Work done is zero if the angle between force and displacement is 90 degree, and work done is said to be negative if the angle between force and displacement is 180 degree. And today we shall discuss energy. Work and energy, they are interconvertible. When energy is spent, work is done, and when work is done, it is stored in the body as energy. Therefore, energy, it is the capacity to do work. The capacity of a body to do work is called energy. And there are different types of energies. They are heat energy, light energy, wind energy, mechanical energy, chemical energy, so on. So many types of energies. And here we discuss about mechanical energy. Then what is mechanical energy? The energy possessed by a body due to an external force is called mechanical energy. When a body is lifted against gravitational force, the work done by the external force is positive, and this work done on the body is stored in it as gravitational potential energy. And when a body at rest, its initial velocity is 0. When an external force acts on the body starts moving. That means here energy is spent to move the body, and this work done on the body is stored in it as kinetic energy. Therefore, mechanical energies are of two types. They are potential energy and kinetic energy. Potential energy, it is the energy possessed by a body by virtue of its position against gravitational field, or its configuration, its shape and size. Therefore, the energy possessed by a body by virtue of its position or configuration is called gravitational potential energy, and the energy possessed by a body by virtue of its motion is called kinetic energy. And today we shall obtain expression for gravitational potential energy and kinetic energy. Let M be the mass. Let consider a block of mass m. It is raised against gravitational force. Let h be the height to which a body of mass m is raised. Then work done on this body in raising it from ground to a height h is given by W equal to f d cos theta, but here theta equal to 0 since force and displacement are in the same direction, that is theta equal to 0, cos 0 equal to 1, hence W equal to f into d, where f is magnitude of force and d is displacement. D is the displacement. Here, what is the force, external force exerted on the body to raise it against the gravitational field, and it is taken as it is equal to weight of the body, and weight of a body is nothing but it is the force with which the body is attracted towards the ground. Hence, here F is nothing but weight of the object, and that is equal to weight is given by mass into acceleration due to gravity. Hence, F equal to W equal to mg and D equal to h. Here D is the displacement of the body from ground level to a height h. D equal to h. Therefore, W equal to mgh, since F equal to mg and D equal to h. And it is found that this work done on the body is stored in it as gravitational potential energy. For example, a body raised at a height, if it is released, it moves towards the ground. Why? Because it has potential energy. It has potential energy, and the work done in raising the body is stored in it as gravitational potential energy. Hence, W equal to PE, that is potential energy or gravitational potential energy, that is equal to mgh. Hence, the expression for gravitational potential energy is mgh, where m is mass of the body, g is acceleration due to gravity, and h is the height to which the body is raised. Similarly, kinetic energy of a body, it is the energy associated with a body by virtue of its motion. By virtue of its motion is called kinetic energy. Let m be the mass of a body at rest. Consider a roller, a body of mass m. Its initial velocity u equal to 0. Since the body is at rest, therefore its velocity is 0. Then what is its kinetic energy? Its kinetic energy is equal to 0, and potential energy is also equal to 0 since it is on the surface of the ground. When an external force F acts on the body in the given direction, the body starts moving. The body starts moving and it covers a distance s, when force is acting on it, the body moves and it covers a distance s. Let here v be the velocity of body. It is the final velocity of the body. Then the velocity of the body when force acts on a body at rest is given by v square minus u square is equal to 2as, where a is acceleration of the body, that is rate of change of velocity, and s be the distance travelled, and u be the initial velocity, and v be the final velocity. Since initially the body is at rest, u equal to 0, if u equal to 0, u square equal to 0, hence v square equal to 2as. V square equal to 2as, or s is equal to, yes, take s on one side, then v square upon 2a. Hence s equal to v square upon 2a. Now, what is the work done on the body to move from initial position to final position? To cover a distance, s is given by w equal to f into d, force acting on the body into displacement of the body, that is equal to work done on the body at rest. Clear? Next, but here f equal to ma, because according to Newton's second law of motion, f equal to ma, f equal to ma, and d equal to s, it is the displacement of the body, hence fd can be written as mas, since f equal to ma and s equal to d, the displacement, that is equal to again write ma as it is into s, but what is s? S is v square upon 2a, that is v square upon 2a. Now here a and a get cancelled, remaining mv square upon 2, a get cancelled. Hence work done on the body to displace from rest to other position covering a distance of s is given by w equal to mv square upon 2. But according to definition, when work is done, energy is spent, and this spent of energy is stored in the body as kinetic energy. Hence w equal to ke, therefore ke, that is kinetic energy, is equal to mv square upon 2, mv square upon 2. Hence kinetic energy of a body is half the product of mass and square of the velocity, and unit of energy, that may be potential energy, kinetic energy, the unit of energy is joule. Clear? As speed increases, here kinetic energy is directly proportional to square of its velocity. As velocity increases, kinetic energy also increases. As velocity decreases, kinetic energy decreases. Clear? So here two important questions for 2 marks. What is potential energy, gravitational potential energy, and obtain an expression for it. It is for 3 marks. What is gravitational potential energy? The energy associated with a body by virtue of its position against the gravitational field is called gravitational potential energy, and obtain the expression as discussed. Then what is kinetic energy and obtain an expression for it? Kinetic energy, it is the energy associated with a body by virtue of its motion is called kinetic energy. Flowing water, blowing wind, they possess kinetic energy. And the expression for kinetic energy is K equal to mv square upon 2. Give example for potential energy. Stored water possesses potential energy, and a spring, when it is compressed or stretched, it also possesses potential energy. Due to potential energy, a stretched spring, when it is released, it comes to its original shape and size due to potential energy. Thank you.